Chapter 5. Gaia, the cleaved planet. Why do we call our planet Earth? In German, it is Erde, from Erde in Old High German, Jord in Icelandic, Jord in Danish, Erthe in Middle English, Erthe in Gothic, and going eastward geographically and backward in time, Eretz or Erethe in Aramaic, Erde or Ertz in Kurdish, Eretz in Hebrew. The sea we nowadays call the Arabian Sea, the body of water that leads to the Persian Gulf, was called in antiquity the Sea of Erythrea, and to this day Urdu means an encampment or settlement in Persian. Why? The answer lies in the Sumerian texts that relate the arrival of the first group of Anunnaki Nephilim on Earth. There were 50 of them, under the leadership of Ea, whose home is water, a great scientist, and the firstborn son of the ruler of Nibiru, Anu. They splashed down in the Arabian Sea and waded ashore to the edge of the marshlands that, after the climate warmed up, became the Persian Gulf. And at the head of the marshlands they established their first settlement on a new planet. It was called by them Eridu, home in the faraway, a most appropriate name. And so it was that in time the whole settled planet came to be called after that first settlement. Erde, Erthe, Earth. To this day, whenever we call our planet by its name, we invoke the memory of that first settlement on Earth. Unknowingly, we remember Eridu and honor the first group of Anunnaki who established it. The Sumerian scientific or technical term for Earth's globe and its firm surface was Ki. Pictographically, it was represented as a somewhat flattened orb crossed by vertical lines, not unlike modern depictions of meridians. Since Earth does indeed bulge somewhat at its equator, the Sumerian representation is more correct scientifically than the usual modern way of depicting Earth as a perfect globe. After Ea had completed the establishment of the first 5 of the 7 original settlements of the Anunnaki, he was given the title epithet Enki, Lord of Earth. But the term ki, as a root or verb, was applied to the planet called Earth for a reason. It conveyed the meaning to cut off, to sever, to hollow out. Its derivatives illustrate the concept. Kila meant excavation, Kima, tomb, Kindar, crevice, fissure. In Sumerian astronomical texts, the term ki was prefixed with the determinative mul, celestial body, and thus when they spoke of Molki, they conveyed the meaning, the celestial body that had been cleaved apart. By calling Earth Ki, the Sumerians thus invoked their cosmogony, the tale of the celestial battle and the cleaving of Tiamat. Unaware of its origin, we continue to apply this descriptive epithet to our planet to this very day. The intriguing fact is that over time, the Sumerian civilization was 2,000 years old by the time Babylon arose. The pronunciation of the term Ki changed to Gi, or sometimes Gi. It was so carried into the Akkadian and its linguistic branches, Babylonian, Assyrian, Hebrew, at all times retaining its geographic or topographic connotation as a cleavage, a ravine, a deep valley. Thus, the biblical term that through Greek translations of the Bible is read, Gehenna, stems from the Hebrew Gai Hinnom, the crevice-like narrow ravine outside Jerusalem named after Hinnom, where divine retribution shall befall the sinners via an erupting subterranean fire on Judgment Day. We have been taught in school that the component geo in all the scientific terms applied to earth sciences, geography, geometry, geology, and so on, comes from the Greek Gaia, their name for the goddess of earth. We were not taught where the Greeks picked up this term or what its real meaning was. The answer is from the Sumerian ki or gi. Scholars agree that the Greek notions of primordial events and of the gods were borrowed from the Near East through Asia Minor, at whose western edge early Greek settlements like Troy were located, and via the island of Crete in the eastern Mediterranean. According to Greek tradition, Zeus, who was the chief god of the 12 Olympians, arrived on the Greek mainland via Crete, whence he had fled after abducting the beautiful Europa, daughter of the Phoenician king of Tyre. Aphrodite arrived from the Near East via the island of Cyprus. Poseidon, whom the Romans called Neptune, came on horseback via Asia Minor, and Athena brought the olive to Greece from the lands of the Bible. There is no doubt that the Greek alphabet developed from a Near Eastern one. Cyrus H. Gordon, Forgotten Scripts, Evidence for the Minoan Language and Other Works, deciphered the enigmatic Cretan script known as Linear A by showing that it represented a Semitic, Near Eastern language. With the Near Eastern gods and the terminology came also the myths and legends. The earliest Greek writings concerning antiquity and the affairs of gods and men were the Iliad by Homer, the Odes of Pindar of Thebes, and above all the Theogony, Divine Genealogy, by Hesiod, who composed this work and another, Works and Days. In the 8th century BC, Hesiod began the divine tale of events that ultimately led to the supremacy of Zeus, a story of passions, rivalries, and struggles covered in the Wars of Gods and Men, third book of my series The Earth Chronicles, and the creation of the celestial gods, of heaven and earth out of chaos, a tale not unlike the biblical beginning. Verily, at first chaos came to be, and next the wide-bosomed Gaia, she who created all the immortal ones who hold the peaks of snowy Olympus, dim Tartarus, wide-pathed in the depths, and Eros, fairest among the divine immortals. From chaos came forth Erebus and black Nyx, and of Nyx were born Ether and Hemera. At this point in the process of the formation of the divine immortals, the celestial gods, heaven does not yet exist, just as the Mesopotamian sources recounted. Accordingly, the Gaia of these verses is the equivalent of Tiamat, she who bore them all, according to the Enuma Elish. Hesiod lists the celestial gods who followed Chaos and Gaia in 3 pairs, Tartarus and Eros, Erebus and Nyx, Ether and Hemera. The parallel with the creation of the 3 pairs in Sumerian cosmogony, nowadays named Venus and Mars, Saturn and Jupiter, Uranus and Neptune, should be obvious, though this comparability seems to have gone unnoticed. Only after the creation of the principal planets that made up the solar system when Nibiru appeared to invade it, does the tale by Hesiod, as in the Mesopotamian and biblical texts, speak of the creation of Ouranos, heaven. As explained in the book of Genesis, this Shamam was the hammered-out bracelet, the asteroid belt. As related in the Enuma Elish, this was the half of Tiamat that was smashed to pieces, while the other, intact half, became Earth. All this is echoed in the ensuing verses of Hesiod's Theogony. And Gaia then bore starry Ouranos, equal to herself, to envelop her on every side, to be an everlasting abode place for the gods. Equally split up, Gaia ceased to be Tiamat. Severed from the smashed-up half that became the firmament, everlasting abode of the asteroids and comets, the intact half, thrust into another orbit, became Gaia, the Earth. And so did this planet, first as Tiamat and then as Earth, live up to its epithets, Gaia, Gi, Ki, the cleaved one. How did the cleaved planet look in the aftermath of the celestial battle, now orbiting as Gaia Earth? On one side there were the firm lands that had formed the crust of Tiamat. On the other side there was a hollow, an immense cleft into which the waters of the erstwhile Tiamat must have poured. As Hesiod put it, Gaia, now the half-equivalent to heaven, on one side brought forth long hills, graceful haunts of the goddess nymphs, and on the other side she bare Pontus, the fruitless deep with its raging swell. This is the same picture of the cleaved planet provided by the book of Genesis. And Elohim said, "Let the waters under the heaven be gathered together into one place, and let the dry land appear." And it was so. And Elohim called the dry land earth, and the gathered together water he called seas. Earth, the new Gaia, was taking shape. 3,000 years separated Hesiod from the time when the Sumerian civilization had blossomed out, and it is clear that throughout those millennia, ancient peoples, including the authors or compilers of the Book of Genesis, accepted the Sumerian cosmogony, called nowadays myth, legend, or religious beliefs. In those previous millennia, it was science. Knowledge, the Sumerians asserted, bestowed by the Anunnaki. According to that ancient knowledge, Earth was not an original member of the solar system. It was the cleaved-off half of a planet then called Tiamat, she who bore them all. The celestial battle that led to the creation of Earth occurred several 100 million years after the solar system with its planets had been created. Earth, as a part of Tiamat, retained much of the water that Tiamat, the watery monster, was known for. As Earth evolved into an independent planet and attained the shape of a globe, dictated by the forces of gravity, the waters were gathered into the immense cavity on the Tiamat side, and dry land appeared on the other side of the planet. This, in summary, is what the ancient peoples firmly believed. What does modern science have to say? The theories concerning planetary formation hold that they started as balls congealing from the gaseous disk extending from the Sun. As they cooled, heavier matter, iron in Earth's case, sank into their centers, forming a solid inner core. A less solid, plastic, or even fluid outer core surrounded the inner one. In Earth's case, it is believed to consist of molten iron. The two cores and their motions act as a dynamo, producing the planet's magnetic field. Surrounding the solid and fluid cores is a mantle made of rocks and minerals. On Earth, it is estimated to be some 1,800 miles thick, while the fluidity and heat generated at the planet's core. The processes that produce, over billions of years, a spherical orb, the uniform force of gravity and the planet's rotation around its axis, should also result in an orderly layering. The solid inner core, the flexible or fluid outer core, the thick lower mantle of silicates, the upper mantle of rocks, and the uppermost crust should encompass one another in ordered layers, like the skin of an onion. This holds true for the orb called Earth, but only up to a point. The main abnormalities concern Earth's uppermost layer, the crust. Ever since the extensive probes of the Moon and Mars in the 1960s and 1970s, geophysicists have been puzzled by the paucity of the Earth's crust. The crusts of the Moon and of Mars comprise 10% of their masses, but the Earth's crust comprises less than 0.5% of the Earth's landmass. In 1988, geophysicists from Caltech and the University of Illinois at Urbana, led by Don Anderson, reported to the American Geological Society meeting in Denver, Colorado, that they had found the missing crust. By analyzing shock waves from earthquakes, they concluded that material that belongs in the crust has sunk down and lies some 250 miles below the Earth's surface. There is enough crustal material there, these scientists estimated, to increase the thickness of the Earth's crust tenfold. But, even so, it would have given Earth a crust comprising no more than about 4% of its landmass. Still only about half of what seems to be the norm, judging by the Moon and Mars. Half of the Earth's crust will still be missing even if the findings by this group prove correct. The theory also leaves unanswered the question of what force caused the crustal material, which is lighter than the mantle's material, to dive, in the words of the report, hundreds of miles into the Earth's interior. The team's suggestion was that the crustal material down there consists of huge slabs of crust that dived into the Earth's interior, where fissures exist in the crust. But what force had broken up the crust into such huge slabs? Another abnormality of the Earth's crust is that it is not uniform. In the parts we call continents, its thickness varies from about 12 miles to almost 45 miles, but in the parts taken up by the oceans, the crust is only 3.5 to 5 miles thick. While the average elevation of the continents is about 2,300 feet, the average depth of the oceans is more than 12,500 feet. The combined result of these factors is that the much thicker continental crust reaches much farther down into the mantle, whereas the oceanic crust is just a thin layer of solidified material and sediments. There are other differences between the Earth's crust where the continents are and where the oceans are. The composition of the continental crust consisting in large part of rocks resembling granite. This leads to one more important difference between the Earth's continental and oceanic crusts. The continental part of the crust is not only lighter and thicker, it is also much older than the oceanic part of the crust. By the end of the 1970s, the consensus among scientists was that the greater part of today's continental surface was formed some 2.8 billion years ago. Evidence of a continental crust from that time that was about as thick as today's is found in all the continents in what geologists term Archean shield areas. But within those areas, crustal rocks were discovered that turned out to be 3.8 billion years old. In 1983, however, geologists of the Australian National University found in Western Australia rock remains of a continental crust whose age was established to be 4.1 to 4.2 billion years old. In 1989, tests with new sophisticated methods on rock samples collected a few years earlier in northern Canada by researchers from Washington University in St. Louis and from the Geological Survey of Canada determined the rock's age to be 3.96 billion years. Samuel Bowring of Washington University reported evidence that nearby rocks in the area were as much as 4.1 billion years old. Scientists are still hard put to explain the gap of about 500 million years between the age of the Earth. This is a tremendous difference that no amount of speculation about rising and sinking continents, forming and vanishing seas can explain. Someone has compared the Earth's crust to the skin of an apple. Where the oceans are, the skin is fresh, relatively speaking, born yesterday. Where the oceans began in primordial times, the skin, and a good part of the apple itself, appear to have been shorn off. The differences between the continental and oceanic crusts must have been even greater in earlier times because the continental crust is constantly eroded by the forces of nature, and a good deal of the eroded solids are carried into the oceanic basins, increasing the thickness of the oceanic crust. Furthermore, the oceanic crust is constantly enhanced by the upwelling of molten basaltic rocks and silicates that flow up from the mantle through faults in the sea floor. This process, which puts down ever new layers of oceanic crust, has been going on for 200 million years, giving the oceanic crust its present form. What was there at the bottom of the seas before then? Was there no crust at all, just a gaping wound in the Earth's surface? And is the ongoing oceanic crust formation akin to the process of blood clotting, where the skin is pierced and wounded? Is Gaia, a living planet, trying to heal her wounds? The most obvious place on the surface of the Earth where it was so wounded is the Pacific Ocean. While the average plunge in the crust's surface in its oceanic parts is about 2.5 miles, in the Pacific the crust has been gouged out to a present depth reaching at some points 7 miles. If we could remove from the Pacific's floor the crust built up there over the last 200 million years, we would arrive at depths reaching 12 miles below the water's surface and between some 20 to nearly 60 miles below the continental surface. This is quite a cavity. How deep was it before the crustal buildup over the past 200 million years? How large was the wound 500 million years ago, 1 billion years ago, 4 billion years ago? No one can even guess except to say that it was substantially deeper. What can be said with certainty is that the extent of the gouging was more extensive, affecting a vastly greater part of the planet's surface. The Pacific Ocean at present occupies about a third of Earth's surface, but, as far as can be ascertained for the past 200 million years, it has been shrinking. The reason for the shrinkage is that the continents flanking it, the Americas on the East Asia and Australia on the west, are moving closer to each other, squeezing out the Pacific slowly but relentlessly, reducing its size inch by inch, year by year. The science and explanations dealing with this process have come to be known as the theory of plate tectonics. Its origin lies, as in the study of the solar system, in the discarding of notions of a uniform, stable, permanent condition of the planets in favor of the recognition of catastrophism, change, and even evolution, concerning not only flora and fauna, but the globes on which they evolved as living entities that can grow and shrink, prosper and suffer, even be born and die. The new science of plate tectonics, it is now generally recognized, owes its beginning to Alfred Wegener, a German meteorologist, and his book Die Entstehung der Kontinente und Ozeane, published in 1915. As it was for others before him, his starting point was the obvious fit between the contours of the continents on both sides of the southern Atlantic. But before Wegener's ideas, the solution had been to postulate the disappearance by sinking of continents or land bridges. The belief that the continents have been where they are from time immemorial, but that a midsection sank below sea level, giving the appearance of continental separation. Augmenting available data on flora and fauna with considerable geological matches between the two sides of the Atlantic, Wegener came up with the notion of Pangaea, a supercontinent, a single huge landmass into which he could fit all the present continental masses like pieces in a jigsaw puzzle. Pangaea, which covered about one-half of the globe, Wegener suggested, was surrounded by the primeval Pacific Ocean. Floating in the midst of the waters like an ice floe, the single landmass underwent a series of riftings and healings until a definite and final breakup in the Mesozoic era, the geological period that lasted from 225 to 65 million years ago. Gradually, the pieces began to drift apart. Antarctica, Australia, India, and Africa began to break away and separate. Subsequently, Africa and South America split apart as North America began to move away from Europe, and India was thrust toward Asia. And so the continents continued to drift until they rearranged themselves in the pattern we know today. The split-up of Pangaea into several separate continents was accompanied by the opening up and closing down of bodies of water between the separating pieces of the landmass. In time, the single Panocean, if I may be allowed to coin a term, also separated into a series of connecting oceans or enclosed seas, such as the Mediterranean, Black, and Caspian Seas, and such major bodies of water as the Atlantic and the Indian Oceans took shape. But all these bodies of water were pieces of the original Panocean, of which the Pacific Ocean still remains. Wegener's view of the continents as pieces of a cracked ice floe, shifting atop an impermanent surface of the Earth, was mostly received with disdain, even ridicule, by the geologists and paleontologists of the time. It took half a century for the idea of continental drift to be accepted into the halls of science. What helped bring about the changed attitude were surveys of the ocean floors begun in the 1960s that revealed such features as the Mid-Atlantic Ridge that, it was surmised, was formed by the rise of molten rock, called magma, from the Earth's interior, welling up, in the case of the Atlantic, through a fissure in the ocean floor that runs almost the whole ocean's length. The magma cooled and formed a ridge of basaltic rock. But then, as one welling up followed another, the old sides of the ridge were pushed to either side to make way for the new magma flow. A major advance in these studies of the ocean floors took place with the aid of CSAT, an oceanographic satellite launched in June 1978 that orbited the Earth for 3 months. Its data were used to map the seafloors, giving us an entirely new understanding of our oceans with their ridges, rifts, seamounts, underwater volcanoes, and fracture zones. The discovery that as each upwelling of magma cooled and solidified, it retained the magnetic direction of its position at that time, was followed by the determination that a series of such magnetic lines, almost parallel to one another, provided a time scale as well as a directional map for the ongoing expansion of the ocean's floor. This expansion of the seafloor in the Atlantic was a major factor in pushing apart Africa and South America, and in the creation of the Atlantic Ocean and its continuing widening. Other forces, such as the gravitational pull of the Moon, the Earth's rotation, and even movements of the underlying mantle, also are believed to act to split up the continental crust and shift the continents about. These forces also exert their influence naturally in the Pacific region. The Pacific Ocean revealed even more mid-ocean ridges, fissures, underwater volcanoes, and other features like those that have worked to expand the Atlantic Ocean. Why then, as all the evidence shows, have the landmasses flanking the Pacific not moved apart, as the continents flanking the Atlantic have done, but rather keep moving closer slowly but surely, constantly reducing the size of the Pacific Ocean. The explanation is found in a companion theory of continental drift, the theory of plate tectonics. The continents, it has been postulated, rest upon giant movable plates of the Earth's crust, and so do the oceans. When the continents drift, when oceans expand, as the Atlantic, or contract, as the Pacific, the underlying cause is the movement of the plates on which they ride. At present, scientists recognize 6 major plates, some of which are further subdivided: the Pacific, American, Eurasian, African, Indo-Australian, and Antarctic. The spreading seafloor of the Atlantic Ocean is still distancing the Americas from Europe and Africa, inch by inch. The concomitant shrinking of the Pacific Ocean is now recognized to be accommodated by the dipping, or subduction, of the Pacific Plate under the American Plate. This is the primary cause of the crustal shifts and earthquakes all along the Pacific Rim, as well as of the rise of the major mountain chains along that rim. The collision of the Indian Plate with the Eurasian one created the Himalayas and fused the Indian subcontinent to Asia. In 1985, Cornell University scientists discovered the geological suture, where a part of the Western African Plate remained attached to the American Plate when the two broke apart some 50 million years ago, donating Florida and southern Georgia to North America. With some modifications, almost all scientists today accept Wegener's hypothesis of an Earth initially consisting of a single landmass surrounded by an all-embracing ocean. Notwithstanding, geologically the young age, 200 million years, of the present sea floor, scholars recognize that there had been a primeval ocean on Earth whose traces can be found not in the newly covered depths of the oceans, but on the continents. The Archean shield zones, where the youngest rocks are 2.8 billion years old, contain belts of 2 kinds, one of greenstone, another of granite gneiss. Writing in Scientific American of March, 1977, Stephen Morbath, The Oldest Rocks and the Growth of Continents, reported that geologists believe that the greenstone belt rocks were deposited in a primitive oceanic environment and in effect represent ancient oceans, and that the granite gneiss terrains may be remnants of ancient oceans. Extensive rock records in virtually all the continents indicate that they were contiguous to oceans of water for more than 3 billion years. In some places, such as Zimbabwe and southern Africa, sedimentary rocks show that they accreted within large bodies of water some 3.5 billion years ago, and recent advances in scientific dating have extended the age of the Archean belts, those that include rocks that had been deposited in primeval oceans, back to 3.8 billion years. Scientific American, September 1983, Special Issue, The Dynamic Earth. How long has continental drift been going on? Was there a Pangea? Stephen Morbath, in the above-mentioned study, offered the conclusion that the process of continental breakup began some 600 million years ago. Before that, there may have been just the one immense supercontinent known as Pangea, or possibly 2 supercontinents, Laurasia to the north and Gondwanaland to the south. Other scientists, using computer simulations, suggest that 550 million years ago, the landmasses that eventually formed Pangea, or its 2 connected parts, were no less separate than they are today, that plate tectonic processes of one kind or another have been going on since at least about 4 billion years ago. But whether the mass of dry land was first a single supercontinent, or separate landmasses that then joined, whether a superocean surrounded a single mass of dry land, or bodies of water, first stretched between several dry lands, is in the words of Morbath, like the chicken and the egg argument, which came first, the continents or the oceans. Modern science thus confirms the scientific notions that were expressed in the ancient texts, but it cannot see far enough back to resolve the landmass-ocean sequence. If every modern scientific discovery seems to have corroborated this or that aspect of ancient knowledge, why not also accept the ancient answer in this instance, that the waters covered the face of the earth and, on the 3rd day, or phase, were gathered into one side of the earth to reveal the dry land? Was the uncovered dry land made up of isolated continents or one supercontinent, a Pangaea? Although it really matters not as far as the corroboration of ancient knowledge is concerned, it is interesting to note that Greek notions of Earth, although they led to a belief that the Earth was disc-like rather than a globe, envisioned it as a landmass with a solid foundation surrounded by waters. This notion must have drawn on earlier and more accurate knowledge, as most of Greek science did. We find that the Old Testament repeatedly referred to the foundations of Earth and expressed knowledge of the earlier times regarding the shape of Earth in the following verses praising the Creator. The Lord's is the earth and its entirety, the world and all that dwells therein. For he hath founded it upon the seas and established it upon the waters. Psalms 24, 1-2. In addition to the term Eretz, which means both planet Earth and earth ground, the narrative in Genesis employs the term Yabashah, literally, the dried-out landmass, when it states that the waters were gathered together into one place to let the Yabashah appear. But throughout the Old Testament, another term, Tibel, is frequently used to denote that part of Earth that is habitable, arable, and useful to mankind, including being a source of ores. The term Tebel, usually translated as either the earth or the world, is mostly employed to indicate the part of Earth distinct from its watery portions. The foundations of this Tebel were in juxtaposition to the sea basins. This was best expressed in the Song of David, 2 Samuel 22:16 and Psalms 18-16. The Lord thundered from the heavens, the Most High his sounds uttered. He loosed his arrows, sped them far and wide, a shaft of lightning, and disconcerted them. The channels of the seabed were revealed. The foundation of Tebel were laid bare. With what we know today about the foundations of the earth, the word Tebel clearly conveys the concept of continents whose foundations, tectonic plates, are laid in the midst of the waters. What a thrill to discover the latest geophysical theories echoed in a 3,000-year-old psalm. The Genesis narrative states clearly that the waters were gathered together to one side of the earth so that the dry land could emerge. This implies the existence of a cavity into which the waters could be gathered. Such a cavity, somewhat over half the Earth's surface, is still there, shrunken and reduced, in the shape of the Pacific Ocean. Why is the crustal evidence that can be found not older than about 4 billion years, rather than the 4.6 billion years that is the presumed age of the Earth and of the solar system? The first conference on the origins of life, held in Princeton, New Jersey in 1967, under the sponsorship of NASA and the Smithsonian Institution, dwelt at length on this problem. The only hypothesis the learned participants could come up with was that, at the time the oldest rock specimens that have been found were formed, Earth was subjected to a cataclysm. In the discussion of the origins of Earth's atmosphere, the consensus was that it did not result from a continuous outgassing through volcanic activity, but was, in the words of Raymond Seaver of Harvard University, the result of a rather early and rather large outgassing episode, a great big belch of the gases that are now characteristic of the Earth's atmosphere and sediments. This big belch was also dated to the same time as the catastrophe recorded by the rocks. It thus becomes evident that in its specifics, the breakup of the Earth's crust, the process of plate tectonics, the differences between the continental and the oceanic crusts, the emergence of a Pangaea from under the waters, the primordial encircling ocean. The findings of modern science have corroborated the ancient knowledge. They have also led scientists from all disciplines to conclude that the only explanation of the way in which Earth's land masses, oceans, and atmosphere have evolved is to assume a cataclysm occurring about 4 billion years ago, about 500 million years after the initial formation of Earth as part of the solar system. What was that cataclysm? Mankind has possessed the Sumerian answer for 6,000 years. The celestial battle between Nibiru, Marduk, and Tiamat. In that Sumerian cosmogony, the members of the solar system were depicted as celestial gods, male and female, whose creation was compared to birth, whose existence was that of living creatures. In the Enuma Elish text, Tiamat in particular was described as a female, a mother who gave birth to a host of 11 satellites, her horde, led by Kingu, whom she elevated. As Nibiru, Marduk, and his horde neared her, in fury Tiamat cried out aloud, her legs shook to their roots. Against her attacker she repeatedly cast a spell. When the Lord spread his net to enmesh her, and the evil wind, which followed behind, he let loose in her face, Tiamat opened her mouth to consume it. But then other winds of Nibiru Marduk charged her belly and distended her body. Indeed, go and cut off the life of Tiamat was the order given by the outer planets to the invader. He accomplished that by cutting through her insides, splitting her heart. Having thus subdued her, he extinguished her life. For a long time, this view of the planets, and especially of Tiamat, as living entities that could be born and could die, has been dismissed as primitive paganism. But the exploration of the planetary system in recent decades has, in fact, revealed worlds for which the word alive has been repeatedly used. That Earth itself is a living planet was forcefully put forth as the Gaia hypothesis by James E. Lovelock in the 1970s. Gaia, A New Look at Life on Earth, and was most recently reinforced by him in The Ages of Gaia, a biography of our living Earth. It is a hypothesis that views the Earth and the life that has evolved upon it as a single organism. Earth is not just an inanimate globe upon which there is life. It is a coherent, if complex body that is itself alive through its mass and land surface, its oceans and atmosphere, and through the flora and fauna which it sustains and which in turn sustain Earth. The largest living creature on Earth, Lovelock wrote, is the Earth itself. And in that, he admitted, he was revisiting the ancient concept of Mother Earth, or, as the Greeks called her long ago, Gaia. But in fact, he had gone back to Sumerian times, to their ancient knowledge of the planet that was cleaved apart.